Okay, in this video what we're going to do is review the pathways that the body uses to store excess macronutrients that come in. So what it is that the body does with the excess energy depends on the type of macronutrient that you have. If the excess that you have is in the form of glucose, then what the body does to store glucose is to use a process called glycogenesis and turn it into glycogen. Remember that glycogen is nothing but just chains of glucose, so it's a pretty straightforward reaction to turn glucose into glycogen. Fats, usually if you eat or are consuming excess fats in the diet, then they can be either stored directly in the adipocytes or in the liver as fat. Alternatively, if there is too much acetyl-CoA being made and the hormonal conditions are right, then you can turn that excess acetyl-CoA into fatty acids and hook that up to glycerol to make fats. So that process is called lipogenesis. Remember too that some of the amino acids can be made into acetyl-CoA, and that's how proteins are stored. The extra energy from proteins is stored as fats. So notice how fats do not connect to glycogen. Okay, you cannot turn excess fats into glycogen. Why not? The reason is that if you look at the pathways by which fat comes into the energy cycle, to break down fats you turn it into acetyl-CoA. To make glycogen from that you would have to turn acetyl-CoA into glucose and then from glucose into glycogen. And this step here from pyruvate to acetyl-CoA is irreversible. Once acetyl-CoA is made, it cannot go backwards and be turned into pyruvate. This is called a committed step. And that's the reason why fats cannot be turned into glycogen. Alright, you'll notice too that glucose is not turned into fats. Okay, so the reason for that is a little bit more complicated, and that's why I put a dotted line here and a plus or minus. It only happens under very rare circumstances. And why is that? If you look at the pathways, if you have extra glucose coming in, glucose is turned into pyruvate. Pyruvate is turned into acetyl-CoA. So theoretically, there's no reason from a metabolic standpoint why acetyl-CoA that came from glucose couldn't be made used for lipogenesis. But the reality is that if you have a certain amount of glucose, it comes in, it gets made into pyruvate, it gets made into acetyl-CoA, and if there's enough oxaloacetate around, that acetyl-CoA just gets sucked into the citric acid cycle and it gets burned. So that's how glucose is treated first. Burning it is the first option for what to do. Okay, if there is excess glucose that comes in, then what happens is the enzymes that take glucose to pyruvate, pyruvate to acetyl-CoA, they get sort of backed up, and there's some excess glucose that gets hanging around. Now, if there's excess glucose, another thing that happens is that hormones kick in, and this pathway here gets activated. So now if you have excess glucose pouring into the cell, it never gets down to making excess acetyl-CoA because it's getting sucked into making glycogen. So it's just a first use thing. There has to be conditions where glycogenesis is shut down in order for glucose to get past this point to pyruvate and for the acetyl-CoA levels to build up, and only then will you have lipogenesis take place. So the key to getting this pathway shut down is that glycogen stores have to be saturated. And our body actually has the ability to make quite a bit of glycogen, more than we typically have in our body. And so that's the reasoning behind it. But if you look at the data, there's actually experiments that tell you to what extent glucose gets turned into fats. And that's described in page 307 of your textbook on one of these FYIs. So if you read that, it describes the experiments that they did. They took people and fed them various diets with excess carbohydrates, and then they had a method to look at how much of the molecules that came in as carbohydrates, they had ways to mark them, wound up in their fats storage. And the conclusions for that was that you had to have 5,000 to 6,000 excess carbohydrate calories per day for a full week before you could fill up those glycogen stores. Okay, remember that the typical diet, just average dietary needs are around 2,000 kilocalories per day. So that means that you would have to eat 2.5, 3 times of excess sugars or pasta, and for a whole week. And while some of us might dream of doing that, that might be something we would really like to do, when you get down to it, that's more than somebody can eat in a day, and you just get full otherwise. Fat, on the other hand, we can pile that on. So once you've made these molecules, where do you put it? So this chart shows you the distribution of the 3 different storage forms that our body has available to it and where they put it. So looking at glycogen, glucose here refers to blood glucose and brain glucose. The glycogen that's stored is primarily in muscle. Muscle, though, only uses the glycogen that's in it for activity. That's what it's there for. And it's not mobilized to supply the body with glucose for other reasons. Okay, the liver, on the other hand, this represents the easily mobilized stash of glycogen. So whenever blood glucose drops a little bit, say between meals, that's the store of glycogen that your body is going to tap into to get more glucose. Okay, but if you look at the calories here, kilocalories, available, 1,200 kilocalories for a 2,000, actually this here, 400, for a 2,000 kilocalorie per day person. You are going to burn through your typical glycogen stores in just a couple of hours. So that's why we have to continue to eat, and we tend to go into a quasi-fasting state if we don't eat every 4 hours or so. All right, triglycerides. We all know where that stuff is. It's in our adipose tissue. And for a typical grown man, they have a stash of 135,000 kilocalories. Divide that by 2,000 kilocalories per day, and that gets you about 70 days before you run out of fat stores. That's over 2 months. So we have enough energy stored in our adipose tissue to live for about 2 months. And if you look at stories of people who have starved themselves voluntarily to death, there was a case in the 1960s, 1970s of some Irish protesters who went on a mass hunger strike, and many of them died. And if you look at how long it took them to completely run out of calories, that's about how long they lasted. It was about 2 months. So that's where the triglycerides are. But adipose tissue is not the only place where we store triglycerides. Our liver actually has a stash that it draws on to tide us over from time to time. So we don't have to mobilize from the adipose tissue. It's right there in the liver, and the liver can shuffle it around and draw on it and get it there immediately. It doesn't require circulation. All right, let's talk about proteins. Okay, so on the surface, it looks like proteins have a huge stash of available kilocalories. But muscle protein is not really a storage form. It has other purposes. That's what we use to keep us going. The glycogen stores and the fat stores, if you got rid of them and you just ate glucose, and if you were just feeding yourself constantly, you would be fine. But if you were to get rid of your protein stores, even, if you were just eating sugar and fats, 2,000 kilocalories per day, you would still die, because these proteins have other functions in the body. So it looks like it's a reserve, but in fact, the main source of protein that the body draws on to handle the variation in energy needs from time to time is actually in the liver. So there is a free amino acid pool that's in the liver, and the liver draws on that. Sometimes it makes other amino acids out of it, sometimes it uses it to make carbohydrates. That's what the body mainly has to play with.